Yep, let's go ahead and dive in. So I guess next slide, if you go ahead, just a couple housekeeping things to begin. There we go. So number one, all participants will be muted throughout the presentation, again, just to kind of keep the audio noise down. On that subject, a little bit about questions. Please do ask us questions throughout today's webinar. There's going to be some really cool concepts discussed. We'll have a chat section in GoToWebinar, and towards the end of the session, we'll have a Q&A session. We'll go ahead and read out those questions, and that way we can get them answered. The webinar is also being recorded for today, and after the webinar is finished, we'll go ahead and send that link out, so that way everyone will have the recording, from today's session. So if you want to go ahead and do the next slide. A little bit about who we have for today. So first up, I will let Mariana go ahead and introduce herself.
Thank you, Trevor. So glad to be here today with you guys. So my name is Mariana Jimenez. I run the laser scanning and scale modeling department with ENG. My background is in architecture, but my core experience has been on project management and BIM management. I'm born and raised in Argentina, and I have more than 8 years of experience in BIM and BTC coordinations for the US. I have done several on-site supports for different BIM projects in different places, like LA. I was working as a BIM manager for Walt Disney Imagineering for a year in 2019, and done several other BIM supports for other cities like Mexico City, Monaco, and Santiago de Chile as well. And as a fun fact, I have beaten the entire ClearEdge 3D team in the reality capture conference last year in Idaho, and I think that's why we are here today.
It was a close game of Jenga, but she did also, she beat me and Justin and Kelly, so she did defeat the whole ClearEdge team at Jenga. So story for a different time. So thank you, Mariana. I guess next is my colleague Justin. So Justin, go ahead.
Yeah, so I'm Justin Domer. I'm a product manager at ClearEdge 3D. So mainly focusing on Edgewise and working with some of the other products. I've been with ClearEdge for almost 8 years. During that time, I've done a lot of customer experience work. I've worked within the sales team, I worked on the development team. So just kind of a diverse set of trying to get an idea of what's going on in the industry. I'm into rock climbing, and I'm currently have been on a 3-week trip in Australia, so that's where I am right now. So it's been good to get out and meet customers, but it's been a long trip.
A little bit early in the morning for over there too.
Yeah, it's pretty early.
Yeah, and then last, I'm Trevor with ClearEdge. I've been at ClearEdge, it feels like since the dawn of time, almost one of the first people there. A little bit about me is I work in the industry strategy group. I do a lot of implementation for customers, taking about kind of implementing scanning technology. Fun fact about me is I really, really love whitewater kayaking. Largest waterfall I've gone off of is about 45 feet, straight off, just plunging over the edge. That's what I do for fun. So that's kind of I guess a little fun tidbit. So yeah, let's go ahead and just dive in and really talk about for today's presentation. So wouldn't mind next slide.
Okay, I would like to start today with a quick introduction of E&J for the people that don't know who we are. So we are a BIM company, specialized. We have more than 50 BIM professionals dedicated to BIM, VDC management, and all over the phases of the project. So we cover design, pre-construction, construction, and facility management as well. And we have more than 15 years of experience working on BIM projects. The rest you can read it. Okay, so just a little bit about the context of the project. So we worked on this project several years ago before the pandemic started, and the entire team was in the office every day. So basically, our client came to us back then with 2 specific requests. So he wanted to have reliable documentation of their facility, and also something that can help them enable easier facility management for the systems and assets. So we knew exactly what they wanted, so we just proposed a couple of the following deliverables. Basically, we proposed it to scan the entire facility, to do laser scanning. So from that point cloud, we would be able to create the Revit models, extract, of course, all the 2D documentation and provide them with reliable drawings for their plant. But also, we thought it was a great idea to propose UBIM. So UBIM is our proprietary software, and it is a cloud-based software where you can have your 3D geometry and your model plus all the data together in a centralized database. So our client could have, easy access for the models and the data together in a cloud-based system at any time. Some information about the site. So the site was located in Washington State, just halfway through between Portland and Seattle. This is the largest underground natural gas storage reservoir in the northwestern U.S. And this particular project has suffered several renovations and changes since the 1970s. So as you can imagine, it had really outdated documentation and not as-built documentation. Since it suffered multiple expansions, they needed, to have reliable documentation for all those expansions. And with this documentation, we would be able to help them meet the regulations and support any type of plant inspections as well. So basically, we found 4 specific challenges for this project. The first of one was the outdated documentation, as I said. So back then, when our technician went inside to do the scanning, they provided him with a really large hard drive with a bunch of documentation that was really messy. There was a lot of hand-drawn documents from different areas that we were not sure where those were located, and other cut drawings as well. So it was really difficult for us to get, nice information to upload to the models and information that we can use to represent, the assets and systems in the models. So on the other hand, we had to create a lot of custom modeling. This is because of the nature of the project. It was not content that you could easily find in the Revit standard library. So we just had to went ahead and model a lot of custom bolts and unique mechanical equipment, and that took considerable amount of time. Another challenge that we found back then was the weather. So as you might know, it rains a lot in Washington State. So basically we scanned in November, which is when the rainy season starts. So we got a lot of delay on the scanning due to the rain season. And the last one, it was a tight deadline. So our FM team and our UBIM team needed the models immediately. So we operated under a 1-month timeline, and we had to create the entire Revit model for the project in that time, in one single month. I brought this graphic here because this clearly represents what a scan to FM project looks like at DNG. So essentially, we started doing the laser scanning. Basically, it is not only go to a site and just bring your hardware and start scanning. There is a lot of coordination that needs to happen before our technician set a foot on the ground. So basically, we coordinate all the needs, accommodation, transportation, to make sure our technician has everything he needs when he starts scanning. For sure, BIM Production, we have a lot of tools that I will dive deeper later today, but regular BIM modeling. Data collection, this was key for this particular project. So we captured the data from 2 different sources, whatever we could find in the 2D drawings, but we also took picture of the assets tags. So in there, we could find information regarding serial numbers, manufacturer information, model numbers, and so on. And that data was collected, loaded into the models, and uploaded to UBIM for enable easier day-to-day operation for our client. After that, whenever we have the systems information, we could set up or drawings or filters and just show, provide, or client with true as-built conditions documentation for their building. And finally, we uploaded the data plus the 3D model to UBIM, and that was all. So this is basically a zoom of our process. This is how we internally manage this type of projects at ENG. So processes and standards are key in our company, not only because they help us ensuring the integrity of our deliverables, but also to make sure our client has the best possible experience while his project is developed. So essentially, we start with a project kickoff meeting. We do the regular PMing stuff, talking to a client, making sure we are all on the same page in terms of where are we going to start, scan, or which deliverables are we going to produce. And finally, the files transfers. So if you're familiar with point cloud, you know that they are really heavy, and they're really heavy files to handle. So we need to coordinate that really in advance in order to avoid rework as well. As far as the laser scanning, so there is a lot of site work, which is the most common one, technician being on site, scanning, defining which specific hardware you're going to use in there, coordinating the mobilization. And what I think is critical here is also the building access. So we would need for sure to provide our technician with a contact point, a person that can help him opening any locked space that he might find whenever he's scanning. Let's say if we have an above ceiling space, for instance, and we are planning to go and scan in that interstitial space, we would need a person on site that can help us, popping up the ceiling tiles. So we really need to coordinate that in advance and make sure our technicians has someone on site that will help him with all these little troubles. Office work, so point cloud registration, breakdown, and model setup, all that occurs after we scan the project. Here we have an important step that is replicating the kickoff meeting with our internal team. So we at ENG are currently remote 100%, and we are not going back to the office. So it's really critical to transmit and to make the team know that what are the steps that needs to be followed, review the scope of work together and make sure we are all on the same page as well. And in here, the common data environment as well, it's critical because we are all remote, we don't have a server anymore, so we need to make sure everybody knows where the files will be used and located. So moving on to the BIM production, we set up the project, just boring stuff, and I think here is the fun stuff. So there is a point where we start discussing internally which tools make sense to apply it in our workflow. So at this point during this discussion, we define, does Edgewise make sense for this project? Do our internal tools make sense for this particular project? So we organize the team and assign all the tasks accordingly. After that, we just move on to the Revit production. We start creating the contents and, the non-story Revit modeling, typical Revit model. And finally, the model QC, and I will spend some time later on talking about this because this is critical to us, and this is why our clients like to work with us, and that's because of the quality of our deliverables. So in my team, we normally use Glue. I know that Glue hasn't aged really well, but since we are all remote, we can, connect to a single consolidated model online and, see all the viewpoints together, and we can really coordinate how those quality issues are going to get fixed. Moving on to the data entry. So here is it's critical for us to define which Revit parameters are we going to use, so we can load the data in an organized way, and then we save a lot of headaches whenever we are implementing UVIM. So we need to define in advance where and how are we going to upload that information into our models. After that, just regular Revit documentation, and finally UVIM implementation. We need to know how are we going to upload the data, how are we going to upload the geometry, and make sure everything is linked together in UVIM. Right. So specifically about laser scanning for this particular project, so we partnered with Trimble back then. we scanned more than 200,000 square feet area. We provided more than 300 scans, and it took us 1 week to scan the entire facility, both outdoors and the small buildings inside those. And we used terrestrial hardware for that. I really wanted to bring this image here because this is how our technician structured the data after he completed the scanning. So this zoning here was the zoning breakdown that our client was familiar with. So we decided to just keep that. So it was easier for them and for us to handle the data. That being said, we just provided them with 13 point clouds. We just try to keep them small if possible. We regularly try to keep our point clouds between 5 and 8 gigs. We can say 10 as well. But because we know our machines are really good and we can really use large files, but you don't know, from your client's team if they are going to be able to handle these heavy files, and also to simplify the Revit work, right?
Did you guys, when you scanned this, did you do it in color too?
No, black and white.
Black and white? Okay.
It was too much, right? Okay, and what was that?
Yeah, that's pretty common. Just know with the images and keep moving.
Okay, so finally we defined a point cloud origin, and well, that's key. I don't know how many Revit users we have in your audience, but we as Revit users know that Revit doesn't like the geometry to be far away from Revit internal origin. So we normally try to make sure our point clouds origin are really close to the building geometry. So this was a spreadsheet scan location metrics that our technician gave to us. I think it was really nice to count with this. It was a really nice way of organizing the data. So basically each RCS file was loaded in this spreadsheet, and we were able really easy to identify to which area each of them belonged to. So here you can see also their scan location record. There is a really small green circle here, with each scan number. So it was really practical for us, to build those RCP files, because we were just using the drawing plus the Excel file, and that was really straightforward.
I absolutely love that little thing right there.
I love that. Right?
Now we get to, I think we got the fun part coming up next. There we go.
Yeah, so basically your deliverables, this were the deliverables of this particular project, but this is what we normally ask our technicians to provide, a structured RCP file that we normally use for Edgewise, and a decimated file for Revit work. So we have a lower density file, easy to use to link different applications like Revit, Navisworks, Pickup, or whatever we need. And finally, our technician provided TZF files. So we were able to see the 360 pictures with Trimble Real Works to complete the modeling or to check any, system tag or equipment tag on site. And that was really helpful, mostly for the modeling scope. So this was the final resulting point cloud. What we did here was just to trim the boundary of our scope of work, because since this was an outdoor scan, there was a lot of data that was captured by the scanner, and we were not really into modeling those. So we wanted to, keep our times down, modeling times down as much as possible. So we didn't want to have our Revit modelers modeling something that was not strictly for this project.
I see. So that's everything. That's like the inside, the outside data, all that right there. That's what you guys
exactly.
Like your final. Yeah, no, that's fantastic.
Yeah, we didn't have time to lose. So point cloud QC, I will spend a little bit of time here. So based on our experience, there is a lot of excitement, whenever you have your point cloud and the team is ready and you want to kick off the project right now. And but something that we have learned with time is that you need to make sure your point cloud is perfect right before you place any geometry in your models. You know, the farther along you are in your project, the more painful will be for your modelers to correct that if your point cloud has issues. So that is something that we learn it in the hard way, and isn't happening to us anymore, right? So registration issues, what am I talking about? So we look for duplicated scans, alignment issues. So sometimes whenever we receive point clouds from our clients, sometimes they are not aligned, you know, orthogonally to our Revit X and Y. And I don't know if how many Revit users we have here, but we know that Revit doesn't like us to rotate systems whenever those are already modeled. So we want to try to avoid those risks as much as possible. Okay.
Yeah, just so you guys actually went through and filtered and kind of corrected the point cloud before you did anything like further downstream. Yeah.
Yeah.
Okay.
Yeah.
Yeah.
All right. So BIM production. Let's have some fun here. So basically, our Revit model, we model all the architecture and structure to an LOD 200 because our client didn't need more than that. We just use the architecture and structure as a context for the drawings, but we're not really into having those with a lot of information. And we focus on the MEPs, so we model everything up to LOD 350. As you can imagine, in this type of project, there is a lot of underground piping that gets not scanned or captured whenever you're scanning. So basically, we just use the provided drawings for connecting the pipes underground. And finally, automation. We have some internal automation tools that we had developed for a long time ago. We're really fun. My team is really fun of you know, automating as much as possible, asking our development teams as much as possible so we can spend more time just checking and making sure our model matches our clients' expectations instead of spend, you know, a ton of time just doing the model manually. So basically, we have some internal tools to model the floors, the roofs automatically, and some other stuff to have fun with. So as far as the BIM production, we work with 10 Revit specialists for an entire month. I can tell you work during weekends as well because our deadline was really tight. And
I'm sure nobody's worked on a weekend before.
Not anymore. So basically what we did to be able to make it on time was to split our teams in different groups. So we have a specific team for doing all the site work, meaning the topo, the architecture, and the structure. And whenever we have all the pipes processed with Edgewise, that same team was taking care of just connecting those pipes in Revit. We had a separate team for doing the hard work, you know, BIM content work, BIM content creation work. We have a separate person working with Edgewise and processing each one zone per day. And we have a separate team working on documentation, and I was working on the QC of each zone back then. All right, that's Trevor's favorite part. Okay, so Edgewise. So in order to start processing our data in Edgewise, we just exported the RCP files. We create the Revit geometry, you know, we just import our Edgewise content in Revit so we can have Revit native components. For sure, we use the Easy Connect tool to be able to, you know, clean up all the pipe fragments and improve all the connections. And we did a little bit of cleaning within Edgewise, and after we just complete that in Revit, but we want to, you know, get rid of the fake positives in Edgewise so we don't bring that into our Revit models. So back then, each zone, we were able to process them in 3 hours. I know you guys have done a really nice job with Edgewise in the past years. So I know, I think we might have been able to process the entire project in 3 hours instead of the 13 zones now. But back then it took a little longer.
Yeah, how big was each zone? I might have missed this on the earlier slide as far as like how many scan positions per zone about?
I don't remember that, but
like
we have a total of, 200. I don't know. We need to do the math, but wow, it was a ton of
A lot
data.
of scans. Yeah.
Yeah.
Understood.
But good thing we can say is that we were able to reduce our modeling production for the pipes at 30%, and that was great because we were, we were on the tight deadline, so this helped us a lot. And in the meantime, our team member was processing the data. We were just progressing with the model, and that is actually how we work today. We day one we have people modeling the background and another person doing the edgewise heavy processing. So this we kept working like this until now even.
So you guys just move and groove, kind of almost like an assembly line approach, just feeding data through, popping out the edgewise stuff, and moving on to the yeah.
Yeah, exactly. And the way we work with edgewise in ENG is that so we extract the pipes and we just insert that into an empty Revit model, just because we want to use our pipe types or fitting specific families for that, and we don't want to bring whatever comes from edgewise to our actual model. So what we normally do is we just import all the geometry in a empty Revit file. We just change all the pipes, change all the fittings, and we just link that within our actual Revit model and bind the link. So we don't bring, any garbage or any things that we don't want to use or accidentally keep using in our modeling process.
I see.
For ENG processing.
Yeah, I do see that the image is actually from the beta. So just as a shameless plug, one of the things that we're working on in Edgewise is being able to work with unstructured point clouds for automatic pipe extraction. And so we're really excited about that. I mean, in this specific project, it would definitely have been a lot easier just to bring in those clipped point clouds that you were using anyways in Revit and just bring that directly inside of Edgewise and extract only the pipe sections that are in those clipped zones. And so that's something where we are coming out with soon, but the ability to just use any data, and that'll be an unstructured recap file or anything else, to just get those same pipes, but not have to bring in the full recap structured project. It's just easy to pass around, and then also just clip out whatever you don't want to worry about. So we didn't have that for this project, but we will soon.
Yeah, and we do have the beta, and we are already testing it. And I think it's great because so we do a lot of scanning, but we don't scan the 100% of the projects we model. So we don't have control of the type of data we receive sometimes. So I think that having the possibility of processing any type of point cloud is amazing for us.
Yeah, we're excited. So soon, very soon.
Yeah. So content creation, as I said, we had a specific team working on this. As you can see, we had different mechanical equipments, piping fixtures, plumbing fixtures, and different things that you cannot get in a regular Revit content library. So the way we model these things in my team is we use in-place models. So we don't like in-place models actually, but we prefer not to use them if we can. But the thing is that you cannot load your point cloud within the Revit family editor, so it is really complicated to trace the point cloud if you don't have it. So basically, what we do, we use model in places within the Revit environment, and we after that convert it into a actual Revit family. Yeah, and that's basically how we make sure we assign those to the right category as well. Well, quality assurance, I can say this is my favorite part. Like, I'm really picky and I'm so intense with the quality. My team hates me. So basically, we have two ways of check the quality of our models. So the first one and the one we use always is Navis. We use Navis. We do visual inspection. It's just flying through the model, checking the model, and making sure your accuracy is okay. You don't have any missing elements. You don't have unconnected elements or overlap geometry. So basically, it's just working your model and see what is in there. Something that we learn internally is that you need to assign responsible individuals for the viewpoints, so you can make sure all of them get applied in the models. The This might sound a little bit silly, but so we use our search sets and colors specifically to check the Revit categories. And so if you are going to implement, if you are going to use your model for facility management, you need to make sure your categories are correct. And the reason I'm saying this is because we normally schedule all the components before we load the data. So let's say I'm doing a model in place because, I'm at my home, I'm just working on my model, I'm not talking to my team, my peers. So I would say, okay, this equipment is a pipe accessory. So, but it actually is a mechanical equipment. So whenever you do this, whenever you schedule that, you won't see it. So you won't be able to manage that. You won't be able to load that data. And this is key. And that's why we use our colors and filters to assign those to the different components and categories. So here you can see I have all my red, all the red components here are mechanical equipment. All the orange stuff here is actually pipe accessory. And we can do that with plumber fixtures and so on. So this is a really easy way for us to turn on and off the geometry and just easy detecting if we have done any mistake in there. So automatic QC, we use Cloud Compare for this one. This is a free software. If you have used it before, it has a bunch of million of features and tools that we actually don't know. We have no idea how to use them. We actually use it only for comparing our model against our point cloud and detecting missing elements or inaccurate elements. So basically, we just export an STL file from our Revit model, and we just export an E57 file from our point cloud. So what we do in Cloud Compare, we set up our colors, we set up our accuracy and tolerances in Cloud Compare, and we just colorize the point cloud depending on whether we are, our accuracy is good or it is not, or probably if we miss elements. So you can easily go and identify what is not accurate or is missing in your model. Basically, what we do is just export that colorized point cloud and insert that in your Revit, in your Navis model. So you can create viewpoints and you can, go back really easy and make all the corrections you need. So for this particular project, you can see here we don't have the bolts because our LOD doesn't require that. But you can identify all your missing elements because of the colors. Here you can see an accuracy issue as well. So you can start creating viewpoints and marking that in your model so you can later make those, get those fixed. And finally, you can just import that colorized data in your Revit model. So it's really straightforward to just go and see the red points and complete whatever is missing. So this is basically how we do the QC in my team. And yeah, I think it's working really well. So data collection, this is pretty important if you're going to if you're going to use your model for operations. Your data needs to be organized, clean, and you need to make sure you understand the relation between the type of data you are uploading. So we upgraded this model to an LOD 500, and we loaded all the assets and systems information in our model. So after that, we can just plug that to UVim. Basically, as I said, serial numbers, model names, manufacturer's name, and system names. So these were the parameters in our components where we start loading all that information. As you can see here as well, we have already assigned the systems information. So you can see there is one system here in orange, there is another in purple. So you can, know that we can already know that our model is complete and ready for FM. So before we go to the UVim implementation, we just did the documentation. As you can see, we used the same zoning, so our client was comfortable with that, was really used to work with those zones. We started setting up title blocks, key plans, and all the boring stuff whenever you are documenting. We just added a little bit of fun because we used PyRevit. So with PyRevit, you can just populate your views, and you can start populating your sheets, creating names and numbering automatically. So we gain a lot of time with that. Finally, UVM implementation. So a little bit of UVM. So UVM, as I said, is our proprietary software, and it's a cloud-based and centralized model with a really, really intuitive way of using it. So basically, what you can use it for quickly locate your critical assets in case of emergency. Let's say you have a flood and you don't know where your shut-off valve is. So with UVM, you can identify, you can go ahead, select the asset, and know to which room it belongs to, in which level you should find it. So you have all this, the centralized information in there. You can also schedule preventive maintenance cycles. You can also train your new personnel in terms of how you're going to operate your project. You can also use it for replacing equipment parts because all the information will be loaded in your asset. And finally, create work orders and check the status of those. COBI file, I don't know how many people here is familiar with COBI, but basically COBI stands for Construction Operation Building Information Exchange. It essentially is a database and you can open it with an Excel file. It has a bunch of tabs over here in the bottom. And this essentially is a way of setting up relation between the data. Let's say this asset is located in this level, in this particular room. It has this specific properties or information, like I said, serial numbers or all the information. You can just connect the data in COBI and make sure it is organized enough and clean enough before we upload that to UVM. What we consider key here is the unique IDs. So with the unique IDs is the way in which we connect UVM with the actual Revit model. So you can use the regular Revit ID in here in the external identifier column, or you can use UIDs as well. So basically, it connects the specific asset in Revit with the data that you are going to upload in the COBI file. So as I said, you upload the data to COBI. You upload the data to UVM through a COBI file. You will upload the geometry and the 3D drawings as well to UVM through the UVM extension in Revit. After that, you have the data plus the geometry up there. You will start building the systems and subsystems. So you have that information in the COBI file, but you need to start setting up the relations between them. Let's say you have a plumbing system, and within that, you want to specify this is your cold water, your hot water, your vent system, so you can set up all of that together. And finally, you can define tags. So you can display different colors for the systems or for the assets and so on in UVM. And you can upload asset pictures. So you not only have the data, but you already know how the asset looked like. And that will really help you identify the asset on site. So with that, we were able to get a data-rich digital twin in UVM. I chose this example because you can see I have selected a valve here, and I have all the information, the operation information for that particular asset. So all the data is centralized and the model is easy to navigate. So for any person that is not a Revit user, he or she can have the data available all the time. He or she can open it with a cell phone, a tablet, or in the machine. So it's pretty straightforward. So finally, how we did to hit the deadline, how we managed to complete the modeling stuff in 1 month. So as I said before, we just split the team in different parts. A team was dedicated to pipe extraction, another team for the pipe connection and site modeling, content creation, documentation, and QC. We did the same with the areas. So we just split our project in 4 different parts, and we set up partial deliverables for our client. So basically, this is how we manage to coordinate and to synchronize within the teams. So here you can see we have the team 1, which was working on the pipe extraction. And while this person was working on that, or team 3 was already modeling the topo, the architecture, and everything, all the context around it. And whenever those pipes were ready, that same team was doing all the connections between them and just cleaning them up. These were our deliverables. This is a true story. This is how we deliver Every Friday we deliver this one part of this progress, and this is how our final deliverable, BIM deliverable looked like back then. Well, I haven't gotten to the end. I have some tips that I wanted to bring up here. It is not as built unless you scan your project. If there are some individuals here that haven't been exposed to point cloud and to laser scanning, I would really encourage them to do so. If you're a building owner and you're not sure if you want to scan your project, I would say just go ahead and do that. I get a lot of questions from our clients, like, is it too expensive? Is it worth it? Is it worth it? Should I scan my project? And I can say it worth every dollar. And so my advice would be just push your BIM managers, your BIM coordinators to request that and to implement this in your project, because it will save you a lot of headaches in the future. So daily meetings, we did that back then, and we keep doing that mostly now because we are remote. So this is essentially so the team can know what the rest of the team is doing. If they have any question, if they have any issues, we can just review that. We normally take between 15 and 30 minutes per day. It doesn't take more than that, but you can make sure if there is an issue, you can detect it as soon as possible and identify if you have any possible schedule deviation. So this is what's critical for us. Split your project in parts, set partial deliverables, validate your project as soon as possible to make sure expectations are met. If you're doing something that is not aligned with your client's expectations, you better know it as soon as possible. And finally, I always tell my team, use Cloud Compare, use all automation you want, but automatic QC will not replace 100% the visual inspection. I'm really picky with that, as I said before, and there are many mistakes, many issues that you can detect in your model, and you won't be able to detect those with your automated tools. So take your time, schedule some time for QC, and walk through the model. Well, here we are.
Perfect. Well, I guess,
yeah.
So now we'll go ahead and open up the floor to questions. I see, just kind of glancing at the questions pane, there are actually quite a few. So now the fun begins. Questions around Mariana.
Okay.
First one, Ron Vandenberg. How many team members were involved on total in the project?
Good question. So we had 10 Revit modelers and 1 person managing edgeways, and myself, I was just doing the QC for this project. So 12 total. 12
total from, okay, perfect. I guess here is either, I guess, Justin or Mariana. I'll let one of you answer this. Is there a way to use a medium like Matterport scans instead of recreating the model in Revit?
I have no idea. I guess it should. There must be a way. Yeah.
Yeah. Well, I mean, I think it's more of, from the asset management. And another question kind of along the lines of why use the COBie if you have the Revit model? So what's kind of the linking that was done, and why go through all this effort for the facility management basically?
That's a great question. We actually don't need to complete the entire COBie, but we need it because it's UBIM's input. So without the COBie file or either an Excel spreadsheet, so you can do it both ways. You can connect UBIM with the Revit model through a regular Excel file, or you can use a COBie file. But since our FM team was really COBie expert, they were really comfortable working with COBie, and they used that. But you don't need to complete all the fields, just setting up the relations and the information you need UBIM to display. But you don't have to complete the entire COBie.
Let's see, another question that came in. It keeps moving on me. Can the online model environment connect to the live feed data from the device at the site? Does this recognize BACnet or other MEP diagnosis languages? So was there any, basically I think that is kind of asking, was there any on-site usage where you could use that FM model and that data and kind of go in the field and find things that way? Are you aware of how that facility was kind of using that data that you guys created, basically?
So you mean when we were scanning or after?
I think after, I believe after, once the FM model was created.
Okay,
You know,
because the reason I'm asking is because even before you get your Revit model uploaded to UVM, you can already load the data. So you can use UVM to capture data on site. So you're taking the pictures and you are getting asset information on site. So you can start uploading that information right before you build your model.
Okay, and then, but any awareness on like what after everything was done to deliver the project, to just what they use that model in the field, and if not, that's really fun.
Well, yeah, absolutely. So they are using it for training, new personnel, and know where some systems can be shut up and those type of things. Yeah.
Gotcha. I think this actually seems like a good question. So you talked a lot about QA of the geometry in the model. One question that came in was, how are you QAing the attributes for the P&IDs that were named and getting everything typed correctly as far as the data that's stored in the that side of things?
Well, there is a lot of work that you can do within Revit. With a regular, Excel spreadsheet, you can just start filtering, regrouping, using multi-category spreadsheets. So there is a lot of things that you can check directly in Revit, mostly regarding assets, types, and names, and component names, and some data that you want to load in Revit. But there is some other data that is easier, to load specifically in Copy. And also, you don't have to complete, the entire data before uploading the model. You can keep updating your data all the time and modifying that because it's a live model. So you can go to UVM, just replace any mistake or any issue or any missing information. You can just go ahead within UVM and complete whatever field is missing information.
Gotcha. Cool. Yeah, another question. What was the allowed tolerance in millimeters for basically, the model from the point cloud? What was kind of your working tolerance?
I think we were using, it was a long time ago to remember that, but we tried to keep it one quarter inch.
Gotcha. Okay, so pretty tight tolerances.
Yeah.
The coordinates, how did you deal with coordinates when scanning and taking this from to CalCompare and again to Revit? How did you kind of keep all the coordinate systems for the point clouds?
That's a good question. Well, as I said, we try to keep the origin of the point cloud as close as possible with your Revit model. So you can really easily change, the coordinate of your point cloud in Recap. But as long as you maintain that relation, you can use the same. You just import the files, and they will work fine in CalCompare because you have the same origin point.
Yeah, gotcha. Yes, we keep getting more questions coming in, so I'll just kind of keep working through those. So let's see. This is a two-part question. So first is for bringing in the edgewise model, so into Revit. So it's mentioned that you brought it into like a blank model, so that you could convert it to the family types that you wanted to do. When you did that, were you linking those files into one, kind of linking those in, or what was kind of your process for as a single pipe? Like, did you bring everything as a single pipe model and link those into individually, or how is that broken up?
We just import the extruded pipes into a empty Revit model. We just an empty Revit model that is created from our templates. So our template will have already the families that we need to use. So it will be a matter of just selecting whatever you want to change and just replace, and for sure changing the pipe types, the information. I know that some components might break whenever you change the families, like the fittings, for instance. But since we are doing scan modeling, we know that we need some flexibility for the content. So our content is already preset with a lot of flexibility, because sometimes you need to do some connections that in the design process you would never use. So our fittings or families already have that flexibility to support that. So whenever we change the families, we change the pipe types, we just save it, we just link it inside the model that we are using, and we just bind that.
Gotcha. Okay, this is an interesting question. Can this technology be used for airport facility maintenance management too, or is it really something you don't feel would be only specific for outdoor structures?
No, absolutely. You can use, so 2 years ago, I was more involved with the FM team, and we implemented the National Bank of Kuwait. It was a 70-story office building, and we did entire implementation with UBIM, actually. We uploaded all the drawings per level, so so our client was able to find the asset not only in a 3D view, but also in the 2D views as well. Yeah. So it took time because of the size of the building, but we were able to implement it. We also implemented Resort World Las Vegas, which is a really huge casino that is under construction. I think it opened last year, mid-year. So we also implemented that project in UBIM. So you can use it for any type of projects, absolutely.
Gotcha. Okay. Let's see. Getting more in here. Is there any tools being used, or after this handed off, is there anything that you know that this client is doing to keep that model up to date and kind of continue to change it and update it, or was it kind of like you guys handed it off and then it's up to them after that?
That's a good question. So whenever we handed off a project in UBIM, we provide with training to our clients' staff. So they can, let's say you have a renovation in your project and you have a new Revit model, you can just go ahead and update your model and your data in UBIM. You have two options. You can just replace the entire geometry for your new geometry, or you can just start adding parts of it, both for the data and for the geometry as well.
Gotcha. So a question that is just coming in, and it's been coming in, is what scanner did you use on the project? So I know, yeah,
I can say it was a really long time ago, because that was back, I think it was end of 2017, and I'm almost sure a technician used the TX6, and Trimble works for processing.
Okay, cool. Let's see. So other questions. The 2D deliverables. So is it all the 3D, and did you do any 2D deliverables for the electrical or any isometrics or P&ID, or was it just the UBIM and Revit as the deliverable?
No, so we deliver the 3D drawings the same as I said I showed a little bit before. Yeah, we didn't model the electrical because that was not required by the client. We just focus on the systems, the background pressure, and the mechanical equipment specifically. Because so sometimes, and I think that some people think that modeling for FM, and you think of already 500 model, and you say, okay, how much detail I have to add to this model? But basically, you need to identify which assets need to be operated, so you can just focus on that. You don't need even to model a really fancy equipment, because it can be a box, it can be a simple geometry in UBIM, because what matters there is the data. But this particular client was really into having reliable as-built documentation of their model, and that's why we took some time to develop the custom content and to take that model to LOD 350 for the modeling and documentation.
Gotcha. Yeah, makes sense. Are you aware of, you guys do any survey control for the scanning, or was it just kind of cloud to cloud across all the different zones?
Well, we did cloud to cloud back then, and we complemented that with some targets. But since it was mostly outdoor work, cloud to cloud was enough for this.
Gotcha. Okay, and so I assume it was kind of register everything together and then break it up into the zones after you had that all set.
Exactly.
Gotcha. Okay. Let's see. More questions coming through. Let's see, get rid of information. So when dealing with kind of the different zones, what was some of the strategies? Because there's going to be overlap with stuff that's created between the zones. What were some of the strategies you used for kind of dealing with that duplication and redundancy in some of the model data and the point cloud data?
Yeah, we just split them exactly following the boundaries of each zone. So we didn't have overlapped data in there.
Okay. Was there a lot of insulation on the project, or was it just exposed pipes for most of the stuff you're dealing with?
It was exposed pipe, if I remember correctly, but I think this is a great question because so sometimes we get that question from the clients, like if my project has insulation, how should I know the size of the pipes there? So we have two strategies. If we do have some base documentation, whatever, we can pick up pipe size or duct size from there. We just model, the geometry as per the drawings, and we can calculate the difference. So we can model exactly the insulation as it is. But if we don't have any information about that, our clients know that we just model to the outside face of the insulation.
Gotcha. Okay. Let's see. I think just from a checking on time, we have a few more minutes here. Let's see. So I guess one question that I have is just, from this point, was there, knowing what technology is out today and anything like that, and this is a couple of years ago, are there any different technologies you'd be using today to speed up this project, and kind of what would you do different if you were to do this project today?
Mm-hmm. Well, I think the software that we have used back then is still useful now, and we have improved our processing techniques and the step-by-steps that we need to complete each specific workflow. But I think what we are basically focused on now is on our internal innovation. So we have a development team internally, and we have a ticket booth. So anytime we just realize we have a new idea or we have something that might help our modeling processes, and something that things that we can use, to complement what Edgeways does, because for pipe extraction we use Edgeways, for walls extractions we use Edgeways as well. But there are some other tools that are useful as well, like our roofs extraction tools, as well as for floor extraction tools, which basically what you do, you just model a flat roof or a flat floor, and you can just crop the point cloud, select the area that you're looking to, setting up the boundaries of your roof, and you just select your roof. It will just take the point cloud shape. So we have gained significant improvements on that, and we are able, let's say you have a 200,000 square feet warehouse, and you can model the roof in 5 minutes. So to my team, so we are always brainstorming of, if I'm doing this 10 times, how can I automate it? And thankfully we have our innovation team, and they are putting their brains and their heads in whatever ideas we have, and they then can really fast create tools for us, and we can start testing them or breaking them and sending them feedback for that. I think for my team, for my Scan2BIM team, which is the team that I lead every day, it's critical. It's something that we want to keep doing in the upcoming years. So we, as I said before, we can spend more time checking, ensuring we are meeting our clients' expectations instead of doing repetitive modeling.
Yeah, so definitely investing in tools and making sure the automation for the teams. That's definitely good. We like that strategy. We as far as that clear edge, that's definitely how we approach things as well. Cool. Let's see. I think, and we are just at the end of the questions here. At the end of time, I think maybe one more question. I saw one. It was, is anyone using? Did you use any drone data, or was it just terrestrial for the whole thing?
No, just terrestrial for this one. But depending on the project, we are used to work with drones. We completed a UCLA campus scanning last year, and we use, for instance, a drone for scanning the entire. So it depends on where you're going to use your model for. Sometimes the drones make more sense, and sometimes you need to complement, your terrestrial data with the drone scanning because you cannot have access to some different spaces. But with this particular project, we didn't find that there was a need of drone scan property.
Okay, great.
Perfect.
That covers. So there's a couple more questions, but I think what we'll do is we'll wrap up for the day just because of for the time. We definitely really appreciate your time, Mariana, and this is a really cool project. Some interesting stuff that you guys are working on and kind of really pushing for. So I am glad we lost all those Jenga games. Less more than one. So apparently we need to work on that. But yeah, we'll follow up with different questions that weren't answered and kind of go through. And again, we'll be sending out, this was recorded and we'll send this out as well. If there's anything you want to look back on and you missed. But yeah, thank you everybody. And appreciate it. And we'll talk to everybody soon.
Yeah. Enjoy the rest of the day, everyone. Thank you for joining us and happy modeling.
Yeah.
All right. Take care, everyone. Cheers.
Bye.